So good evening, one and all. Welcome to the April AF Mixer for the SOAREX homebrew group. And let me just find my standard disclaimer here. Please note that our meetings are recorded and made available on our YouTube channel. So it's understood that you've accepted being here by participating in the meeting. So anyway, nice to see you all. And Frank, nice to see you back on. It's been many moons, I think, since you've joined us. So that's great. I heard you comment that you're here to revisit the project from about 8 years ago, I think it was. Yep. Michael refreshed my memory on. So yeah, very good. Your name was plastered all over the document. I see that Michael sent me. So.
Oh, okay.
Trip down memory lane. Did you dig out your? Did you dig out your signal source kit?
I've sold it.
Oh,
actually, yes.
Right there you go. Probably to me.
Yeah. Well,
to Kevin.
I bought a new Helicrafter one.
Right. Okay, so Kevin's the honorary holder of the Frank Roberts rig. I hope it's signed.
Good.
All right. Okay, well, also, I think I have this here as well to improve everybody's experience here. Consider lowering your performance settings on Jitsi if you start running into connection issues. Adjust it downwards a little bit, and also disabling video if you're not talking. It saves a little bit of bandwidth for everybody, or during when somebody else is doing a presentation. So, well, I had a couple things that I wanted to mention at the beginning. One of them just dawned on me that here we are in April, so that means we're 2 months away from Field Day. So once again, I'm happy to host Field Day at the farm here for anyone that wants to come up, so we can talk about that in a little bit more detail further on. But I have nothing on that weekend at the moment. As far as I know, it's the very last weekend in June, the 28th and 29th. So perhaps pencil that in on your calendars. And if you want to come out for some camaraderie and trying out of equipment, things you've been working on, some dulcet tones from the theremin or other devices, come one, come all. So anyway, just like I said, here we are. It's just over 2 months away from that fateful weekend. The time is going by fast. Quarter of the year is already over. So what else do I have here? I don't think anything that can't wait till the end of the meeting. I just have a couple other things, but not... Whoop. Sorry, guests. Oh, thank you. Thank you, Peter. We do have somebody new on our call here, I believe. Although I don't see them now on my screen. I presume that's what you were referring to, Peter, right?
Yeah, there was there's one identified as JG, and there was a Kevin, another Kevin around.
Yeah, I did see that his picture come on, but not showing on my screen. I presume not on anyone else's. So could have been a Hoot the Rebel or something, maybe. I don't know. But JG, who's that? Like Jeffrey Goldberg or something? Who knows? Anyway, you never know who's on a chat, I guess, right?
Well, let's get JG to introduce himself.
You'll have to unmute first.
Okay, come on. Does nobody get the joke? All right.
I don't subscribe to the Atlantic, Eric.
At least I thought I'd get somebody, okay, fine, I'll disconnect. All right. Okay. All right.
It was a good try.
I know. Some levity, but all right, we got a serious bunch here tonight. But anyway, whoever that was, this Kevin, does anybody know who? Anybody was expecting anyone to come along? No?
No.
All right. Well, anyway.
Was that Hassan's friend?
No, that's not Kevin. That's a Jeff.
Oh.
But not a Jeff G.
No, Jeff P.
All right. Anyway, okay, well, I guess we'll get right into the thick of it. So we have a short talk from Michael, characterizing our 2017 homebrew project, the 4x4 signal source. So if you are ready to take it away, Michael.
I am. I'm just going to share my screen here.
All right.
There it is. Window. Okay. Should be able to see that, right?
Yep.
Yep.
Looks good.
I wonder if I can make this thing go properly. Oh, good. It works this time. Okay. Yeah. So I built this signal source and in 2017, and I foolishly agreed to do a presentation on it tonight. Interesting. I just wanted an interesting exercise in using my spectrum analyzer, which is one of the reasons I did it. Anyway, a bit of history. It was a Park Homebrew Buildathon project in April 2017, and Frank was involved deeply in this, one of his, I think. And this is what it looks like. And
Michael, your slides aren't advancing.
No?
Oh, we're just seeing the main
okay.
presentation screen.
Thank you. I'm going to have to
just share another window.
Yeah,
or
do it this way. Okay, that work?
There we go. Yep.
Okay, good. Okay. Yeah, I can't figure this out. Sometimes it works and sometimes it doesn't. Mostly it doesn't seem to work for me, so easier to do it this way. So yeah, it was a homebrew project in April 2017, and this is what it looks like. It's in one of the little cans, not a tuna can, but it's a small one anyway, and it produces 4 different levels of output of 50 microvolts, 10, 5, and 1 on 4 different bands. And this is what it looks like inside. For the life of me, I can't think of what this case is called, but anyway. So the board, the background?
Altoids.
Of course, Altoid. That's right, exactly. So inside is a little PC board, and it has 4 crystals here. And they are 3.56, 7.03, 10.116, and 14.060. That being, I guess, the standard convenient frequencies the crystals were available. There's an on-off switch, which is right in here, like this. That's it right there. And there's a bunch of attenuator pads here that either there's 2 pads and a 20 dB pad and a 14 dB pad, and by moving the jumpers around, you can select what you want. So, yeah, I use my spectrum analyzer and just plugged it into the source here and into the SA, and that's a signal of sorts there, I think. But anyway, so this is the circuit. It's got DC coming in this 9-volt battery here with the little on-off jumper thing here, bunch of resistor to control the voltage, and then the rest of it, all this stuff is an oscillator. It looks like a Colpitts oscillator. I'm not quite sure if it exactly is, but it's got the 2 capacitors here, that provide the feedback loop, and the crystals go in one at a time by moving a jumper that connects whichever crystal you want in place in the circuit. And here's the pads, and if the pad is out, not being used, it just goes right through by means of moving this little jumper here, and likewise this one. And it's got a 56 ohm resistor here, which I take to mean it's 50 ohms output, more or less. So, okay. So what I did, I set up my spectrum analyzer and set the RBW bandwidth to 1 kilohertz or 400 hertz as it seemed to be needed. After discussion with Peter, I fiddled around with the preamp, using the preamp either on or off. Didn't use any external attenuation because the signal levels were so low. And I adjusted the internal attenuation just to get results I thought I could trust. So yeah, this is the results. The 50 microvolt or 10 or 5 or 1, the equivalent dBm calculated from a formula. And these are the results I got for the different frequencies, different crystals in service. And the stated in the manual, it talks about minus 73 dBm. And what I got was a bit less than that, about 4 dB less, which maybe explains why these other numbers are a bit lower as well. But anyway, on the 80 meters, 40 meters, 30 meters, and 20, I got minus 77-ish for the 50 microvolts. On the 10 microvolts, I got, should have been 87. I got 91, 93, 93, 93. Going a bit lower on the 5 microvolts, lower again. And likewise on the 1 microvolts, which I was surprised I was able to see. And I had to fiddle with the attenuation. Had to have virtually no attenuation, internal attenuation, and I had to have the preamp on for some of these things, some of these results. And I also had to use the 300 hertz RBW, which means the display or the cursor, if you like, or goes across this display really slowly. So they're more or less consistent. I don't like this result here. It doesn't seem consistent with the others. Not sure why that is. Couldn't make it consistent either. So I sort of gave up at this point. And so those are the results. So it's more or less as advertised, I thought. Anybody got any comments at this stage? Sounds like not. That's great. Unless somebody does.
Yeah,
sorry,
Michael, Dave has a question for you. Go ahead.
Uh-oh. Yes, Dave.
Yeah, Michael, do you want to talk about these slides now, or do you want to talk about them at the end?
Doesn't matter to me, whatever you want. Talk about it now if you like.
Okay. No, because what would be interesting here is if you put the SU units, because from what I remember...
Or if I did what? The S units.
The S unit, like minus 73 dBm, what's that, a S9? You know, minus, minus
okay.
87 is what an S5, something like that.
Yeah, that's a mistake, by the way, where it says plus 73, it should be minus, of course, and 50 microvolts, I understand to be S9, I think.
Yeah, S9. Well, and I think that's, and Frank, you may want to jump in here. I think that was what the intention was here, was to have like the, what's the Elecraft XG3, which is used to calibrate your S meters. So So I think that's what the intention was for this device. It wasn't meant to be like a source, a calibrated source. It's meant to give you approximately what the output is. And I think this is amazing. The numbers I'm seeing here, that it's that close. So if you look at minus 73, all the values across the board, it's going to show up as an S9, right?
Oh, yeah.
And the same thing with that minus 87 and the minus 93. That 14 megahertz outlier could be, because maybe something is acting as a capacitor at that high frequency and it's bleeding through. Who knows? But anyway, I think these numbers look good, but I don't think we need to get hung up on the actual values. That it's approximately close enough. And I think that was what the intention of the XG3, wasn't it?
I wasn't involved. I don't know. Maybe Frank knows.
Yeah, basically, it was a version of the XG3, but the intention back in 2017 was in ham radio at that time, we didn't get down to the fine measurements. Basically, it was if it's plus or minus 10%, that was within spec. And Dave is right with regard to the dB measurements, that they probably better, or it would be a good idea if they were added to it.
Yeah, okay. I'll do that. I'll find out I'll put the S units, but certainly 50 I know is S9. Pretty sure that.
Yes, it is.
The others I don't know offhand, but yeah. So I was quite pleased actually to be able to get the SA to work, to get it to do what I wanted it to. I don't know what this. Yeah.
Sorry, Peter has a question when you're ready.
Sorry, I don't know what this number at the bottom here. That's obviously looks to be wrong to me. I wasn't able to really get any lot of confidence in the bottom figures. They seem to be okay, but I don't really know. Go ahead, Peter. I can't see, by the way, who's asking. That's the thing, right?
Okay, just a little further information on there. What the beginning of the project was. This circuit originally came from Dwayne, who we haven't seen him for quite some time, but off of his blog. And now if you looked at the schematic, you will find that there's a TLB 431.
Here's the schematic.
Component in there. Originally, Dwayne had an LED in there, and if for a one-off unit, that would have been fine. But because it was going to be a buildathon for several of them to be built, if every time when you put in a different LED in there, even if it's the same color, the result were varying quite widely. So the change from Dwayne's original circuit would have been this TLV, because that now putting that reference in there, it solidified so that everybody's device was more or less the same output. Whereas if we'd gone with just LEDs, it would have been all over the place. Anyway, a little bit of information.
I was going to talk about it a bit later. Maybe I tried to simulate the circuit in LT Spice. First problem I ran into is I couldn't get this TLV model anywhere, so I just gave up. But it looks to me, I am right. It is more or less a Colpitts oscillator, isn't it? It's supposed to be. Anybody remember?
I don't.
Yes, it is. I do remember it. It is a Colpitts.
Yeah, because of the two capacitors here, right?
Yeah.
And instead of the Colpitts oscillators, excuse me, the Colpitts oscillators I have seen have had the output taken off the emitter, not the collector, but same difference. Okay. All right. Let me carry on here. So yeah, there's the results. And here's this is where I tried to simulate the circuit. And what I did, I had the motional parameters for a 3.5 megahertz crystal, which we did with the SNA. We calculated those, and I put values in here, the values for the 3.5 megahertz crystal. I hope they're the right values. I'm not so sure now, but I think they were. Anyway, I couldn't get it to oscillate, and this is a standard. This is the same circuit, and I couldn't get it to oscillate in LT Spice. And I understand there are ways to make it happen by forcing an output by some kind of pulse output, perhaps, to give it a push to make it start. But this circuit didn't start. So, anybody got any comments?
I've not had myself personally. I've not. I think I've only done one oscillator, maybe twice, and I didn't have any problems getting to oscillate. But I certainly have read a lot where people had to do extra things, introduce some noise into the circuit or something like that. But otherwise, I don't know if anybody else around here has had experience with trying to get LT Spice to oscillate.
I did get an LT Spice circuit to oscillate some time ago. It was just a copy it was a Colpitts oscillator somewhere, and I just copied it and it worked. But this one doesn't. And I, to be honest, I don't know whether, when I looked at this the other night, I wasn't sure whether these are the right values for the motional parameters anymore. So I'm gonna go have a look at that some other time. Anyway, that's really all I have to say.
Okay, Ken had his hand up first there, Michael. He's got a question.
Yeah, go ahead, Ken.
Yeah, I don't remember. I don't think I actually worked on beta testing, alpha testing. I think I was just kidding these for Frank. But what I ended up doing was I had built it before the buildathon, and it seemed to be working correctly. I couldn't tell what numbers I was getting out of it. But what I ended up doing is I replaced the attenuator resistors with carbon resistors. And what I actually did was take a V file and cut a V in them to get the values as close as possible to what we needed. At the buildathon, I put it on Simon's analyzer, and I was so close to the values.
Isn't that interesting? So are you saying that the values in the schematic here were not the right ones?
So they're the right values, but you got tolerances, right?
Of course, yeah.
And those 1%, they're not solid. They're actually a strip inside. So if you were to try to take one of these and the same method, you would actually cut the resistive strip in it, and then the resistor would be dead. Now, if you use carbons, they're solid. So what I did is I took a very small V file and I cut notches in it, put it on the ohm meter, and then just filed away and let it sit for a while, and it held its value.
Isn't that interesting?
Yeah, and then when I went to the buildathon, I had Simon test it, and I was almost bang on.
Isn't that interesting? Wow. Yeah, I've heard of that. I haven't talked to anybody who actually did it. That's really interesting.
Yeah, I actually saw at that time I was looking at a YouTube video, and this is what the guy in the video was doing. But it has to be carbon. You can't use 1% or anything wound.
I guess the carbon resistors would be the ones that went into the old Heathkits, wouldn't they? Probably.
Yeah. Well, you can still buy 5% or carbon 5% at sale too. So I have a bunch of those in my stock, and plus I got the 1% as well.
Yeah. Anyway, that's the story, and just another opportunity to use a spectrum analyzer, which is sort of, I did the testing months ago, and I went back and redid it, and basically as an exercise to see if I could figure out how to use the spectrum analyzer properly, and guess I got it more or less right. But anyway, that's all I have to say. I'm going to go back to not sharing, unless anybody's got any other questions.
I don't see any other hands up at the moment. So
Okay.
I think that is it.
Okay. I'm going to go.
Oh, Sorry.
Okay, Dave,
You're
go ahead.
almost safe. You're almost safe.
Almost got away.
Almost. Dave has some commentary. Please go ahead.
Hey, Michael, could you put the LT spice simulation up
Sure.
again?
Yeah, right here. Yeah.
Okay. What I would do here, here's a couple of tips. I would take that oscillator, that crystal, take it on its own, feed a small voltage to it through a resistor. Obviously, you got to put some kind of resistor to allow it to oscillate, and see if you can just get the crystal itself to oscillate. Forget about all the other stuff. Like break
Right.
it down piece at a time. Get that crystal. The crystal on its own should resonate and it should oscillate. Okay.
You mean the LT
So-
Spice? You're talking about LT Spice model. You're talking here.
LT Spice. Just take the crystal alone, take a voltage source, feed it to it, and you'd probably have to add a resistor in series with it, because if you put a voltage source directly to it, it can't pull the voltage source down. So it won't oscillate. So you got to put a large resistor to allow it to pull that voltage up and down, right?
Okay.
Do you see what I'm
Yeah, I do.
So,
Yeah.
and I would to get that crystal model to see if that's the problem, see if it's resonating. Okay, next, if that's resonating, the next step, I would take that diode up there at the top and the voltage source and the voltage divider resistors, R14 and R15. I would get rid of that, and I'll just attach a voltage source there at what the voltage there is supposed to be at VR2, and just try and get that to work. And once I get that working, start adding in that voltage divider and the diode and so forth. Because right now you don't know if it's the crystal that's the problem. You don't know if it's the voltage source that's a crystal, or it's the actual circuit you've modeled there with the 2N3904. So that's kind of that's the way my head works. That's the way I would kind of troubleshoot that. So
All right.
anyway, that's all I have to say there.
Yeah. Okay. By the way, what is the one? Anybody know what the 1N4148 does to the circuit here? Why bother with it? Because it's an AC signal, maybe.
No, because it's probably doing for the voltage drop. It's dropping the voltage down by 0.7 or 0.5 or whatever.
So you get the right voltage on the.
As Peter said before, I think that diode should be to ground because it's acting as a zener to set a voltage reference to VR2. And that's what I'm saying. If you get rid of that diode, not voltage divider and all that stuff, and you put a voltage source to what the voltage is supposed to be at VR2, then once you get that working, then you tweak the other piece to figure out how to make that work. But I think Peter can comment better on what the function of that diode. But I seem to remember the diode was to act like a kind of like a zener to pull the. I think the diode goes to ground. I'm not sure. But anyway, let Peter chime in.
Okay. Okay, that particular diode that you're showing there now, I'm not 100% sure what that is in there for now. But the TLV, which you don't have in your circuit there, that's nothing. That was nothing more than a precision shunt regulator, and that was to stabilize the voltage so that everybody would end up with the same results on the output. Okay, whereas before when the original circuit had an LED in there going to ground, which would have been ahead of that D1 diode, the results were all over the map. So that's why we went and switched to that precision regulator. So to Dave's point, get rid of R14 and 15 and all that, and just have a voltage source going in there.
Yeah,
and that would be fine. What that particular diode was, escapes me at the moment, unless it had something to do with we needed a voltage drop there. Maybe Frank might remember.
Nope, I don't remember that diode. I do remember the LED sessions that we had with it and the problems we had there. And then we came up with the voltage regulator, which solved all the problems and was bang on. So we got consistent results all the way through. But Dave is right. Instead of using this type of a circuit, take that out and put in the voltage. I forget what it was now, but you can look up the specs for that voltage regulator and see exactly what the specs say and put that value in as a voltage supply.
Okay. Yeah, I think I looked at something that looked to me like it was 4.5 volts, which is why that the voltage between R14 and R15 is 4.5. I thought that's what it was, but I'll go back and have another look. Yeah, I didn't investigate very far with this. I just tried it out to see if it would work, and it didn't. So I gave up.
Michael, Charlie has a comment he'd like to bring up.
Yeah, Charlie.
I just looking at this, my suspicion would be that the diode is also preventing that voltage divider from loading down the oscillator. It's preventing currents from, flowing back into the divider.
Yeah.
But a precision regulator is certainly the way to go for this. It will have a fairly high impedance going into that where you've got VR2 written on that node. A precision regulator would have a high impedance at that point, which is really critical to allow this thing to oscillate.
Yeah. Okay. All righty. Well, thanks.
Hassan has a comment as well.
Yeah, I seem to recall that there were two LEDs in the circuit, and we spent like a couple of weeks debating what they're for. And one of them was basically a poor man's Zener, and the other one was probably just like an on switch. And I think the thought was, well, why don't we just replace the second LED with a diode because it's cheaper? And so it could be what Charlie said, isolating the circuit, although a cap would have done the same thing. But I think it was actually spurious.
Cap won't work, Hassan, because you need DC going through there.
That's right. You got to get DC to the collector.
Oh, right. But if it's a diode, then it's blocking only in one direction, not the other.
Correct.
So it's actually introducing nonlinearity in harmonics. So, but I think this was actually spurious. I mean, I don't know what else you could have used, like an inductor, maybe. I don't know. How else would you isolate these circuits, the DC from that side?
Whenever I built these sorts of circuits in the past, I would have used an inductor there. You're quite right.
So it would have, I guess for a small, but there would have had to be an inductor with a cap. So it's low pass filtering. So it presents a DC voltage and maybe like a choke, an RF choke or something.
Yeah, that's what you want to choke.
Right. But I think the diode was just to save money, because in the original circuit, I think it was an LED, which was a power LED, power on LED, I think.
The original circuit had an LED going from the left side of D1 to ground.
That was the poor man's Zener?
Yes.
And
it gave the results were between different LEDs were wide. The output voltages were quite different. So in other words, if you're building in a group of these things, you kind of want to have the results to be more or less the same. So since we couldn't count on LEDs, because I can remember trying LEDs that came from the same package and they all gave different results. So that's why it was decided to go with the precision regulator to stabilize that. What D1 was for, like we've said before, I can't remember. Who knows? Maybe it was just there for noise. Get this thing oscillating. I don't know.
Okay. Well, thanks.
Can you roll back to the schematic for a second?
Sure. Right here. Yeah, there it is. There's the diode right there.
Okay, so I'm wondering too if that's a 0.6 voltage drop from the regulator. I don't recall the numbers that we had before. That's like 12 years ago.
Yeah.
Well, it could be to revert if you hook the battery up backwards. prevents the circuit from destroying itself.
You
It
would
would
do
do
that
that.
on
It
the
would do
other
that for
side.
sure. Yeah.
You'd do it on the other side of that regulator.
I've just been going through Dwayne's blog and I can't find it. I found it. I found his notes when we met up with Dwayne at 4 Days in May, and he wrote up a little bit there on our buildathon based on his project, which he was quite pleased with. But I haven't found his original circuit.
Okay. My diode arrangement where in the LT Spice stuff on the left-hand side where I had that voltage source, that was all to mimic this stuff. In particular, this regulator thing, which I didn't have. So, okay, fair enough. Well, thanks very much.
Okay. I don't see any more questions or hands raised, Michael. So, yeah, thank you for sharing that. And you can
okay, we'll go back.
Screen sharing now, I guess. Yeah, perfect.
Yeah, okay. All right.
Okay. All right. Thank you very much, Michael. Appreciate that. Nice walk down memory lane, I think, for a lot of the group here. So before we continue on, just wanted to give a welcome now to Kevin in the interim. See, you've made it on and it looks like your connection is stable. So are you able to maybe do a little radio check here, a little audio? That would be Kevin KJN, of course.
Still muted.
Yeah. So I'm not sure if Kevin KJN is with us or not, but
I am.
Oh, there you are.
I'm sorry. I'm not as familiar with Jitsi as I am with all of the other meeting applications. So sorry about that.
Yeah, no worries. Okay, well, welcome. So are you connected to one of us here, or how did you find out about our group?
Well, I joined the KREX group, and then I got these emails indicating that you folks get together. So this is the very first time. I've only been at a few KREX meetings, and I guess I'm getting the invitation to join this meeting. So I thought, well, maybe I should try that tonight and see if find out what it's like. So I'm assuming I'm allowed to be here. I hope so.
Oh, open to one and all,
sure.
Absolutely. So yeah, you are out in I guess Drew and Peter's neck of the woods.
And Howard.
Yeah,
Howard. Yes, right. Yeah.
I apologize. I didn't put my call sign on. So VE3 kilowatt Japan November VE3 KJN. So there is a QRZ page.
Yeah. No, very good. So, well, welcome. I presume that you like to get your fingers burnt with soldering irons as well?
Well, I just more or less retired at this point, and I've spent most of my career in telecommunications, electronic engineering technology, and IT. So the short answer is yes. So I'm into a number of things. I've only been operating on ham radio for about 4 years, but I've got into many modes in both on HF and 2 meter. I run a DMR repeater. I put a tower up. I'm doing some automation. We have a couple acres, but I built an irrigation system, and I'm doing work on platform IO with ESP32 chips and automating much of what we have in terms of sensors and water irrigation, things of that type. So I'm into microprocessors. None of which I did probably for the last 25 years because I was in management and IT and stuff. So in any event, so I'm very interested in electronics. So I've just set up a bit of a ham shack / electronics lab. I have a digital scope and a few other things that I've kind of started to equip. I'm envious with those who talk about spectrum analyzers. I kind of wish I had one of those. So yeah, I'm into a lot of different hobbies, but certainly electronics has always been my passion. And so I built up quite an inventory of parts related to automation, and I'm embarking on sort of a major effort to automate our greenhouse, which we just put together last year. So
Nice.
Anyway, so I have a background. I have my pilot's license, and I've done radio control, and I've flown actual full-scale aircraft, and and I do boating and fishing in the spring and things like that. So anyway, I'll stop there. I don't want to tie up the group with all that stuff.
No, that's great. Okay, well, it sounds like you're a good fit for our group. I did actually pull up your QRZ page, and it's quite an impressive little panoramic view you got there of your operating position. I thought I had a lot of screens, but wow. So
yeah, being an ex-IT guy, I have a virtual environment set up. I run 5 separate VLANs, and I have a virtual server set up as well, fairly large box that I set up a number of virtual machines on. So I'm hoping to do some work with that as well. And so, yeah, I'm into a little bit of everything, probably too much, but my origins all are electronic engineering, and I love it. So that's what I'm trying to get back to now.
okay, well, very good. Great to have you here, and I might have to pick your brain offline. I don't understand how you can get a Canadian call sign and within 4 years. That's surprising to me. That's a little inside joke. So we'll start.
That'd be an insight, all right.
That's because he applied himself.
Well, I just finished my advanced, so I have my advanced license. So I'm fresh off of that as well. So, and my brother just got his as well. So we're both into electronics. So we convey back and forth quite a bit on electronics.
Very good, very good. Yeah. Okay. All right. Well, we again, we welcome you here.
Okay.
As you might have gotten from the, I'm not sure what the nature of the posting that you saw, but this is a very informal. I mean, all of our meetings are relatively informal, but this is our sort of round the water cooler or I don't know, casual party mode or something, where we don't really have a in-depth formal presentation, but we have little short ones, short and sweet, I guess, and then usually go around the table, so to speak, the virtual table, and talk about various topics, what's going on, and we're going to try something new this evening with regards to that. But anyway, on the third Wednesday of every month, we've got our regular meeting where there's, like I said, usually 1 or 2 more in-depth presentations. So yeah, you're welcome to come again, and yeah.
Thank you.
Please feel free to jump in if you ever have any comments or questions. So it's great.
Thank you.
Have you joined the SOAREX group online?
Have I joined what? Sorry?
Yeah, Groups IO for SOAREX.
Let's see. Well, I joined the KREX group, and so I'm getting emails, which is what I got here, saying that this was a mixer. Is that correct?
Right.
Yeah.
Correct.
Yeah. So I assume that's why I received it, but I'm not part of anything else at this moment. But I'm just kind of getting started, I guess. Like I said, I've just kind of, I guess, fully retired now. So I'm kind of just partitioning what things I want to try to get involved in and participate in. So I'm kind of new to the whole game.
At least you don't have messy hair like the other Kevin.
Well, don't ask me whether I would prefer that or not. I might be surprised.
But he does have a Canadian call.
I wish I had messy hair just like Kevin. So
you got to have hair first.
Yes, that's right.
Eric,
That's right. I'm working on bangs. I'm going to have bangs maybe for the next meeting. So
Eric, just a second.
Kevin,
I put in the chat the link to our Groups IO.
Perfect.
So
Perfect.
you can just request to join through that link if you'd like.
Okay. With the chat there. Okay. As I said, I'm just still getting familiar with chat. Let's see. Okay. I'm just looking for it now. Thank you. Oh, I see it. Yes. Thank you. So I don't mean to prolong that, but is it you folks, SOAREX, that's down Toronto area, is it?
So it's Southern Ontario. So,
Southern Ontario.
Yeah. So basically, yeah, wide swath, amateur radio experimenters, Southern Ontario. So
We have
in the U.S.
We have members from Kingston down to Windsor.
Down to Georgia.
And Georgia.
To Georgia.
North to Pembroke.
Correct.
And I guess, is there an inventory of things that you folks are working on or interested in, things like Mesh Tactic or LoRa or anything, those types of technologies? Is is it kind of open season on whatever, or?
Yes.
Yeah.
Pretty much. Yeah. There's often a flavor of the month or what have you, or discussion in the groups.io. But yeah, absolutely. We're somewhat of a wandering of, if I could call it intellects, that's what we do. So
Okay.
we're part of the Peel Amateur Radio Club several years ago, but we have struck out on our own. And the signal source unit that Michael was talking about was one of many dozens of kits, test equipment, transmitters, receivers, transceivers that had been done back in that time. So there is quite a back inventory of projects that we've worked on. And most recent, SOAREX was a direct conversion receiver project that wrapped up after a long time last year. So yeah, no, whatever somebody brings to the table, if it has to do with communications of any sort, we're all over it. So
yeah, great.
Yeah.
So Frank, when did you start the homebrew group with Park?
Frank still monitoring. He might be.
There we go. Yeah, we started in 2003 with our very first project, and it was a transceiver. So from there, we've gone pretty well the spectrum of operating equipment, test equipment, and lots of ins and outs. And we're very early in the software-defined radio technology, and we didn't carry on too much with that, but we did build a receiver for it. And it's been just a host of different items until a lot of us are getting a little old, and that's the problem. But the young ones there, they can carry on, and we welcome all of the projects that they may come up with.
Yeah, that's great, Frank. Actually, this might be a good segue into something I did want to bring up during this meeting, which is access to all of the documentation files and what have you. I was asking Michael just a couple hours ago for a copy of the signal source manual, and where is that accessible? Is there an online source for all of this? Because I'm no longer part of the Park homebrew groups IO. Whether there's any files there or not.
There are some files there, but it's not complete of everything. And you can still access it, but they're not complete for all our projects. I don't think there's much online for our documentation for our projects over the years.
Yeah, because Michael had a link to one of the Park HB, for a document there. But again, I couldn't access it. You have to be a member, I guess, which I am.
No, you don't have to be a member.
You just have to join Groups IO, I think.
Yeah.
Just be a member of Groups IO. You don't have to be a member of Peel.
Rejoin.
You can still access the homebrew files.
Yeah. Okay. Now I'm just thinking we should probably have that on our Google Drive, right? That was why I was bringing this up, is that it could disappear at some point. Does anybody have a repository of all of this? The 22 years of documents and all that, because we should get that under our domain at some point, right? So
I backed everything up.
Yep. Is it? So maybe we can talk about getting that onto the Google Drive. Yep.
If someone is going to organize it, I can probably fill in some of the missing pieces from the original manuals that I wrote. And from the early days, I might be able to scrape up something, but I'm not aware of a repository other than bits and pieces around the ham radio stuff. Some Park has some, and SOAREX has some. So if somebody wanted to organize it, I'll be happy to help.
All right. Sounds like a project, because like I said, I looked through our Google Drive folder, and there's not much there. Dave's presentations and some of his files, that's about it. We had talked about it sometime last year, I know, using that as our source because we have free storage there. So Kevin.
Yeah, I know I have a bunch of the manuals, certainly not all of them. And I have the SS manual from Frank when I bought it. I mean, I can scan that and we can do an OCR on it. But I have a number of electronic copies of the originals. So
I think most of the stuff is already in soft copy. Like I have, Michael just sent me a direct link to a soft copy of the signal source manuals. So.
Oh, okay, all right.
And I know there's one for one for the signal generator as well somewhere. I did see that.
I have the original. I wrote it, so I've got the Word document if we want that. But
yeah.
Okay. All right. Anyway, all right. That was all. I didn't want to belabor the topic here, but that's something I think we should probably do sooner than later, just to get it archived. So archived and available. Okay, Peter, you were on the revised agenda, I guess we'll call it, for talking about probe specifications. You had something to tell us about.
Yes, we've got all the characterization testing and stuff pretty much done. We went through 3 different versions of the probe, and the only difference is really between the 3 different versions was the input cap. Originally we started off with 100 nanofarads, then we went to a 1 picofarad cap on the front end, and then we tried a 0.5 puff on the front end. So got all the results in from the various testing and put them all together, could make some comparisons, and then Dave and I met up for a coffee when he was driving through Kingston here last week, and we put together some specifications for the probe. And the numbers that I'll quote you are conservative. So no matter who builds what and how you build it, you should be able to get at least this at a minimum. It'll probably do better than what the numbers that I'll quote you, but at least these ones you can talk about it and be safe to know that if you build it, you're going to at least get this performance out of it. So we decided to go to the 1 picofarad probe. Mainly because there's still a little bit of gain to be had with the 1 puff front end. If we went to the 0.5, you might have a little bit better input impedance and that kind of thing, but you also had a little bit of a negative gain on it. So the difference between the two were so minor, really, we decided let's go with the 1 puff and have a little bit of gain. So the gain here is safely we can get 2 dB gain from 3.5 to 30 megahertz. The bandwidth spec will be from 300 kilohertz up to 120 megahertz. The maximum signal that you can put into the probe without, and this is to be keeping the harmonic that the probe produces at 40 dBc. So that's just a number we picked as to be able to make a measurement. So the max signal would be minus 10 dBm from 3.5 to 30 megahertz, and your harmonic that's generated is 40 dBc down. The minimum signal, we can easily get to minus 95 dBm right across the HF band. Again, there we picked the minimum signal that we saw was 10 dB above the noise floor. It was just the way that we measured it. So you can see that, you could go much lower than that, but we had 10 dB as a safe. So minus 95, no problem. The input capacitance, we figure it's about less than 2 puff across the HF band as well. So that was good to see. The input impedance, that's an interesting subject in itself. Best guess would be about 23K. I shouldn't say guess. There was a lot of work put into this, so it's a little bit more than a guess, but still. We figure about 23K at 3.5 megahertz, and we're down to about 3K at 30 megahertz. So those are the specs of the probe. Now, another little discussion that we had, we talked about maybe having the ability to piggyback an outboard amplifier on top of the probe. So for those that might be interested in, especially if you don't have a tiny SA or a spectrum analyzer, because this is what the probe was originally designed for. But there may be some out there that don't have that equipment, and you want to use it with your scope. So I did a little test here, and I'll just show a couple slides quickly. You can see that?
Just a black screen at the, oh, there we go. Got it.
Okay, so here's the probe without an amplifier on it. This is what you can see now on your scope.
Hold on a second. I don't see it. I just got to, oh, there it is. Okay, got it. Thanks.
Okay. So I inputted a minus 60 dBm signal, and this is what I was able to read on the scope. This is just directly off of our probe. So that's pretty good. You can make a measurement there. Now, I did put an averaging on this. The way it's set up right now with just using the bare probe on your scope, you'd have to use averaging because the signal would be a little bit too messy. But anyway, there it is for minus 60 as it is now. And here is a minus 70 dBm signal. And again, you can start seeing a little bit of hash here and stuff like that. If you didn't have any averaging on, it would be really quite messy. But you know what? You can see it. So an outboard amplifier bolted onto the back end of the probe would probably make this a little bit more useful. And you can probably get another. Well, it depends on what the gain is on your probe. But you can see right now you can get down to minus 70. So I'll stop sharing there. Now, maybe as a quick show of hands, or I don't know, who's interested in building the probe? And who's interested in building the probe with an amplifier on top of that, even maybe, So, okay. That's good.
I am interested in building the probe. I don't think I need the amplifier.
Well, you got an SA?
I do.
Ah, very good.
I have a tiny SA.
That's the same thing.
A very tiny SA.
Okay. Anyway, we're progressing. We're getting close to really now we're probably going to start finalizing exactly what we want to do on the front end and the back end of the probe, meaning like what kind of probe do we actually want on it and how we're going to power it, et cetera, that kind of thing. And then we should be pretty close to really ordering the first version anyways, or maybe hopefully the first version board that we put out there will do the job. So anyway, it's looking promising. We're getting close. And I think that's it for me on there, Eric. Thank you.
Okay. Any questions for Peter? I see no hands at the moment. I presume there probably would have been already. So, okay. Thank you very much, Peter, for the update. We will move on. We have our next probe meeting tomorrow, if I'm not mistaken, tomorrow evening. So, okay. So we are going to move on to the round the screen segment of our meeting here to pretty much the second part of our gathering here tonight. So in the past, we've done a what's on your bench, what were you currently working on, what projects, what have you. But in a similar vein to how a lot of nets on the radio actually over RF work, often there is a topic of the day, topic of the net, whatever you want to call it. So we're going to try that, which is a little bit, outside of the box compared to what we've done. So this is the brainchild, I think, of Dave and Peter, but great idea. So something a little different, and that way you don't have to struggle necessarily if you don't have a whole lot going on your bench at the moment. So it's going to be putting you on the spot perhaps a little bit, because the topic of the discussion here is, what's the most embarrassing moment that you've had working on your bench? Have you have you had a moment where you've given yourself an electro boom kind of shock, or something where you forgot to turn something on, troubleshooting for hours and realized, oh, power switch was off, whatever it is. So with that preamble, we'll start off with the esteemed originators of this event. And so I guess maybe Dave, we'll start with you. I'm sure there's plenty of embarrassing things, I'm sure maybe even some of those blades above your head there have maybe given you a close shave once in a while. Yeah?
Geez, which day? Like, what day do I not do something embarrassing in my shack? Geez.
What hour?
But like, yeah, what hour? It's like, geez, like starting with like, here's my, can you guys see the mods here on my Z80 board? Like, can you see that spaghetti mess? I don't know if you could see the like not knowing how a momentary switch works, which I know how it works, but I didn't put it on the board. But no, I think probably I could say the most detrimental mistake I've made was connecting my spectrum analyzer to the Dueling 612, which was the precursor to the Phoenix radio, and not having enough attenuation. And I blew the front end of my spectrum analyzer out. And it's like, what, Peter, it's a $1,500 US piece of equipment. So blew that out, been there, done that. But like, again, what day of the week? Anyway, that's it. Next.
So maybe, I don't know, maybe we should have a little, like at the end, you say, what lesson did I learn? What do I do now? Do I always leave an attenuator attached to the front of my SA? Is that the lesson?
Yeah, absolutely. I have some rules in terms of using my spectrum analyzer. First one is crank up the internal gain to the maximum, right? Whenever I connect anything to it, and I make sure the preamp's off. And I always put, at least about 10 or 20 dB external attenuation. If I'm doing a power amp, I'll probably have about 40 dB of attenuation. And I've got like attenuators that does high power, right? It's got fins here, and does high power. So I can attenuate like, 10, 15 watts of power in there. Yeah, like that. Anyway, next.
Okay. Thank you, Dave. All right, Peter.
Nice. Yeah, like Dave says, there's a lot, but there's a lot of us here tonight. So maybe I'll just relay one. And it was fairly recent. It was about a year or so ago, I guess, or maybe it was longer than that. But anyway, I bought a new signal generator, the Siglet, and unpackaged it and raring to go, and start trying it out. And I spent, well, I'd like to say 2 days, but I might have even gone into the third day trying to get this stupid thing to work. And I was at the point where I think I was actually going to bundle it up, and I thought I'm going to have to ship it back to, was it RCC or RLL? I can't remember the name of them. And because I could not get the thing to generate the frequencies that I wanted. And, I'm talking about in the HF frequencies. Well, what it turned out to be in the end was I didn't pay attention to the capital M and the little, in the little m. So there's like millihertz and megahertz. Well, millihertz was right where my fingers were when I was punching in the numbers, and megahertz is at the very far left of the screen. Not that it's that huge of a screen, but so I kept pushing the micro or the microhertz or millihertz, I should say. Anyway, this went on for quite a while, and I think actually it was Michael. I was talking to Michael about it, I think, and Michael kind of said something to me that either he said, dummy, there's a capital M, or whatever he said was, it made me take another look at it, and that's what it was. So I spent 3 days with finger trouble on that sucker. So that was probably the one of the most embarrassing ones. I mean, there's a few stories about letting the smoke out of stuff, but we could probably cover off on that another day.
So what's the learn from that?
Well, this goes against the grain of everybody here, I think. It's probably read the manual, read the screens.
RTFM. Yep. All right. Very good. How about Michael? Do you have anything that you could share with us as far as embarrassing moments?
Regretfully, I do.
Yeah.
I
just pick one.
Following on from what Peter was saying about before I start, I have learned from Dave about what not to do with the spectrum analyzer, and I leave 20 dB attenuator on both sides usually, and sometimes even a 50 ohm attenuator, 50 ohm load on the input, because just after I bought the spectrum analyzer, it got fried because the power supply died. I think because I had linear amplifier at the time, and I think voltage got impressed on the supply, 120 volt supply to the SA. I was very lucky that RCC took it back and gave me a new one, which I thought was under warranty, but it was nevertheless, I was very lucky. In terms of Peter's experience, I have to say that I have the same signal generator he does, the SGD 1032, and I was doing some testing with the probe using the signal generator and the scope, and I set everything up and turned it on, and the scope is showing square waves. It's supposed to be a sine wave, and it's showing square waves. So I tried this was on it has two inputs, and I tried the first input. It's showing square waves. The second channel was fine. So I thought, what's going on here? And I had the warranty on the signal generator runs out at the end of April, and this was just 5 or 6 weeks ago. This was happening. So I thought I looked up when I bought it, and sure enough, it was still under warranty. Something I have to send this thing back, and then I realized that on the display, on the buttons on display, there's a little one that says burst, and it was lit up. I thought, oh, that's interesting. So I pushed that, and it went out, and magically the signal generator is back to normal. And that only took a day and a half to figure out. And what it is, the burst function, it sends, you can set up to send 5 or 6 or 10 or whatever it is, or one cycle of a signal. It just does the 1 or the 10 or whatever. And I had, by pushing the burst button, I had turned that function on. And so I didn't have to send it back, which was a good thing. The other thing I've done, you talk about not providing power to things. I was fiddling around with this probe board, and nothing worked. And then eventually I realized I haven't given it 12 volts. Of course it didn't work. But that's about it for me so far. Doesn't mean I won't make other mistakes. I once blew a capacitor on, I was building there was a field day over voltage generator circuit, basically consisting of, it used one of the GFI circuits for an outlet, for a wall outlet. and I had a capacitor spectacularly fail. I had put something in, I think I put the diode in backward. There's a diode there, put it in backwards, and the whole thing just exploded with a little spiral of material dielectric coming out. It was really spectacular. Anyway, that's about it for me, as I say, so far.
All right, very good. I'll just keep on recording all those things for future episodes. That's great. All right, thanks, Michael. That's great. So I think maybe we'll go around the screen now. Charlie, how about yourself? Anything that comes to mind as far as most embarrassing moments?
Truly, my most embarrassing moment was back when I was actually working and near the beginning of my career. I was working in research and development. We were building a new custom IC for a specific job. The prototype shop put together the chip that we had designed and delivered the first samples of it, and the first samples turned out that the bus that you talk to the device over was implemented upside down, basically backwards. The bits were going the wrong direction on it. So the prototype shop very quickly took one of the samples over and they put it under a scanning electron microscope, and using a laser, they blew out tracks in it and then put these minuscule tungsten pegs in and welded wires to reroute tracks inside this, tiny little thing the size of your fingernail. Put it back into a case again and delivered it to my desk. And I said, great, I'm going to go down and start testing this thing out. And I took it down to the lab. I plugged it in backwards and blew up the only working device on the planet. So yeah, that was probably the most embarrassing one for me.
All right, that's a good one.
Yeah. And less than was the rest of the team after that said, Charlie, go do some paperwork at your desk. We'll take care of this stuff over here for you.
Very good. Very good. Okay, thanks for sharing that, Charlie. Cherry, you got something to share with us as far as embarrassing moments?
Yeah. So this was at a time when I was a student and I was trying to, make some extra money by selling some something called the tube light ballast, or what do you call it, tube light choke. So in our place those days, there was a lot of voltage variations with the hydro, or in a place where I was born and brought up in India. So we had this voltage variations throughout the night time, which would actually flicker and cause problems. So most of the people used to use this fluorescent tube lights, which function with the something called the electronic choke. And it used to be so stable because it also contained a doubler and then a little bit of stabilizer, and then it would do. It does have, I believe, a chopping circuit along with with a toroid. So I got the circuit from somewhere, and then I made the first prototype quite successfully. Just to play with that voltage a little bit at that time. I did not treat it quite seriously because we had 240 volts in India, but then and it will be doubled, and it is going to this fluorescent tube light, which I used to play with. Luckily, nothing happened, but the embarrassment was not that one. Actually, there was a toroid inductor inside of this, and it had multi-winding. There was a primary and a secondary, but a small toroid actually. I don't remember what kind of choke was that, but what kind of toroid was that. But I don't know the type of that toroid. But what happened was, the first time I wound that toroid, it went well. I got the circuit working, and I thought, yeah, this is great. Like, let me make the second one, right? Then I started with the second one, and it will not work due to some reason. I checked and double checked everything. It seems all right. There is no soldering joints, no problems. Yeah, but I could not figure out why it's not working. Finally, I thought, okay, one of my winding is like the other way, so there is some, maybe there is something with the direction, like, of winding. And then I just took out that piece alone and rewound the whole thing. And I just looked at the first piece which I made and did the same way. And I got it functional. So then I knew there was something. And then I found that there was something called phasing associated with the toroids, which I never took seriously before when I was learning the stuff. So that was quite an embarrassing moment, because I never knew phasing and what was phasing or how it is critical for this circuit. So that was a good learning point. And then I found myself reading more, and it quite that failure helped me a lot in building later units. I think I made 10 to 20 of them, sold to different people, made a little bit of money at that time. So that was my embarrassment moment. Thank you.
Okay. All right. Thanks, Jerry. Appreciate sharing that. Thank you very much. All right. Frank, how about yourself? I'm sure you've got lots of stories, so you can maybe share just one of them.
Are you saying Frank has made a lot of mistakes in his life and
Well,
he doesn't know what he's doing?
Oh, I would never say that. No.
Not the father of our homebrew group.
No, not at all.
That's very true, and I'm still making them. But going back, I have to go back to, let me see, in 1961, about 64 years ago, and my most embarrassing screw up. I was assigned to install their first computer in Madrid, Spain. And the idea was to go over there and spend 3 months training the staff, the people that are going to support it, and then to actually install. So during that time, I don't know whether it was the training part or it was the installation part, but they had ordered all brand new equipment, brand new spares, test equipment, everything, and the best of the best at the time. And they had ordered a brand new Tektronix scope. Well, the power plug on a Tektronix scope, this one anyway, was identical to what we have in Canada. So without even thinking, I plugged it in. Well, turns out that their power standards use exactly the same type of plug as we use, only it's 220 volts. And boom, zap, and there goes their thousands of dollars worth of Tektronix scopes in front of the whole class. So if you want an embarrassing moment, I think that's about the biggest one I've had. So back to you.
Yeah, well, you certainly let the smoke out on that one. Wow.
Oh, for sure.
Yeah, nice. And that was so long ago. That was like, you said 1961. So that's 10 BE. Wow. That's a long time ago.
Oh, yeah.
Wow. Okay. All right. You know what? Since I'm kind of the next on my screen here that I'm looking at, I will share an embarrassing moment from about a year and a half ago or so when I was building a guitar pedal. And yeah, well, it had a little Arduino Nano in it, and I was building it with a bunch of other people, and I was, cajoling them, telling them, just make sure you know, uh, very careful with the way that you're, putting it in. Make sure you observe the polarity of it, so to speak, the direction, because it could go in either way, and coaching everybody along, and because I've soldered enough things in my time. So when I got, of course, to finishing my pedal, having all 40 pins or whatever it was soldered in, suddenly occurred to me that I had put it in backwards. Needless to say, I got very, very well acquainted with solder suckers, braid, and I think I made a mess of what I was doing there, so much so that the instructor said, "Here, you can just take mine, and we'll call it a day." So yeah, sometimes you need to listen to your own advice, I guess. And I didn't let any smoke out, but it was before I applied power to it, but pretty sure it wouldn't have worked backwards. So anyway, kind of an embarrassing moment, since I was uh, trying to be the guru of the group. So anyway, there you go. Hassan, what have you got for us? Anything to share as far as?
Yep, two stories. One is I decided to cover my desk with this steel plate because I figured, well, cheap ground plane, great idea, except that I had an FPGA board which I set down on top of it and shorted out the backside. So ruined. So that's one story. Second one was I was playing around with those 433 megahertz modules, the pair that come. And so I hooked one up to, battery and small Arduino or something, and it was transmitting. And I was amazed at the range. And I'm walking around the basement with two of my friends, and we're just amazed that it works all the way across the other end of the basement. And weeks later, I'm realizing, wait, this thing's supposed to have a 4 kilometer range or 2 kilometer range. Then I realized there's pins where you're supposed to solder on an antenna. So I was using it without an antenna, and I'm amazed that I get like 20 feet of range. So that's the second story. So I I, I didn't clue into the fact that you're supposed to put an antenna on this thing.
Yeah. All right. Very good. Very important for RF. What can we say? All right. Ken, how about yourself? You got something to share with us?
How many do you want?
The biggest one.
Okay.
One
I
that
got
makes
my
you sweat.
yeah. I got my license in '77 in high school. '79, I went to my to college the first year. They had a ham shack. Call sign was Victor Echo 4 Romeo Romeo Charlie, or Red River College. Uh, so I think a month after going the first year, I met up with the dean of the department, and we were just talking and everything. And he had mentioned that they had a shack. They had the Drake twins. They had the old RTTY machine and everything. And when I had no classes, I was hanging out there. There was a couple other guys in my classes that are licensed too. Um, I'd say maybe 6 months later, uh, I don't know how I met these two hams. They were older than me, I'd say in their 30s. At that time, I would have been, what, 19, 18, 19? And I sort of became chummy with them. And uh, one day they said, well, there's a contest this weekend. You want to compete from the college? I said, sure, why not? So it was one of these 24-hour ones. I don't recall which one it was. So we started the Saturday morning, and then through the night, and then to late afternoon on Sunday, and then it was over, and we went our way. Um, the following Monday or the next day, I get to class. I'm in my 9 o'clock class, and all of a sudden, the dean of the department comes to the classroom. He says, "I need to talk to you. Come to my office." So he had gone back, and then a couple minutes later, I go to his office. I sit down, close the door. He says, "So I understand you were operating a contest this weekend from the shack." I says, "Yeah." He says, who were the other two guys with you?" I says, "A couple of guys I know that I met quite a while ago, whatever." And he says, "Do you know those guys had their licenses revoked from the Department of Communications?" I said, "No, they didn't even say anything." And I said, "I didn't even know that. They didn't even say anything." So he says, "You should have checked with me first. You're banned from the shack for the next 6 months." So I had to find other things to do on my breaks. And that's it.
All right. There you
And
go.
of course, after 6 months, I was able to go back and hang around with the other couple of guys that were in there.
Did you ever hear from the other two again?
No, because the dean had contacted the DOC at that time and reported these guys again. They knew where these guys lived, so.
Were they
And you're
US
still
by
doing it.
chance?
What's
You're
that?
still doing it today because you let Eric operate with you. He doesn't have a Canadian call sign. You're still doing it.
That's okay. I'll tell them my name is Eric.
All right. Thanks, Ken, for sharing that. Kevin, KJN, you're next on my screen. Would you like to share anything with us on your inaugural meeting here?
Well, the only thing that comes to mind at the moment, I'm sure I've made lots of stupid things, but I was only into ham radio for the first year, and I was getting in pretty heavy on the digital side of things, digital modes, and building MMDVMs on top of Raspberry Pis, and getting so involved in different digital modes like C4M, FM, and stuff, and of course hotspots and whatever else, and repeaters. So I guess the simple, not as anything as dramatic as what I've heard so far this evening. This will be boring, but I basically was doing a lot of testing. I didn't have a dummy load yet. I kind of, so I wasn't transmitting much power, but I was playing around with digital modes and stuff, and I inadvertently connected to traffic in Texas, I believe it was. And inadvertently, the frequency I chose was one of the input frequencies to our repeater here in the Kingston area. Actually, it was a C4 FM, and I didn't realize it. It was running, and I left the shack, and I guess it ran most of the day, because then I heard about it because they were able to trace my call sign back to see where the source data was coming from. So it wasn't a very active repeater, but nevertheless, they were not very happy with me. So that was probably the most embarrassing as a newcomer to ham radio as well. And I felt terrible about it and apologized 1,000 times. But so not really a bench kind of thing, although it kind of was, but not like I blew up a transistor or something. But that's the one that came to mind when you asked that question. I probably, give it more time, I could come up with some other worse things that I did. And probably a lot of the things I'm going to do going forward, as I am now have more time, and I've got I bought a signal generator and a digital scope and a bunch of other things. So I'm probably set up now to blow up something else, I bet. But that's about it.
Okay, great. Now there you go. You had the ham police after you pretty quick, right? So,
oh yeah, I did.
Yeah, good. Okay, appreciate sharing that. Thanks, Kevin. So on to the next Kevin. If he's still there, yes, he is.
Yeah, I'm here.
Yep, Stratford Kevin.
Stratford Kevin, yeah, just running around listening to all the stories.
Yeah.
Well, mine's a recent. Yeah, mine's a recent one, but not a high. Well, it is high tech, but not really. just the other day or the other week when I was trying to get the op amp presentation, and I'm connecting up a little circuit just to see if I can make it work and whatever, play around with it. And the first thing I do is, it's like, this thing's not working. What the heck's going on? Well, I forgot to put the power supplies on. So there's that. And then when I did put the power supplies on, I put them on backwards. So it's like the chip was instantly non-functional because plus and minus 15 on the minus and plus 15 doesn't work so well on these chips. So anyway, it was, I haven't done a lot of shack work lately, and obviously I'm out of practice. So it's time to get back in the swing of things.
Yeah, I can never remember, red is positive or negative.
Does it matter?
All right, very good. Thanks for sharing. Al, you are not last, but I'm sure not least either.
That makes me the penultimate, doesn't it? Anyhow,
Not quite, almost penultimate. Second to penultimate.
Oh dear, what could I say? I think one of my biggest embarrassing situation is the number of projects that have never worked. I can remember as a teenager, remember the great construction articles and radio electronics, popular electronics. Oh, by golly, I tried a lot of those things, and I could solder things together, but the only test instrument I had was a VOM. So when they didn't work, I was reduced to just poking and prodding and maybe giving it a bang on the table and ultimately putting it on the shelf and never really working. So fast forward to, I guess, around 1976. Anybody remember Southwest Technical Products? They were a kit company out of Texas, I think. And I bought a thing called the Tigosaurus power amp. It was an audio power amp. And I built this thing. Well, it didn't work, of course. That's my my way of doing things. And I was in high school at the time, and I got all my buddies together. And for about 6 months, we looked at this, prodded this, changed components, everything. Ultimately, destroyed the PC board. I was able to get a new artwork and make a new PC board, put it all back together, and this time it finally worked. What ended up being was a large power transformer into a large heat sink, and one of the wires was grounded out. It only took 6 months and a complete rebuild to find it out. And the most embarrassing part is there was a line in the manual that said, be very, very careful of this. But did I read the manual? Not really. I was in a hurry. Anyhow, that's basically my story. Oh, and one for Michael as well. This is a little more recent, probably 5-6 years ago. I picked up an old Heath kit. Is it an HW7? Is it the QRP radio? And it wasn't running, so I took the lid off, plugged it in, got power onto it, and I remember hearing a noise, kind of like frying bacon. I put my nose right in there, my ear right up to it. I couldn't tell where it was coming up. Stood up, turned my back to it, and it was about 1,000 microfarad aluminum tin capacitor. Blew up like a 12-gauge shotgun. Scared the living daylights out of me. Bits and pieces of paper and dielectric all over the shack. And just thinking, had I not looked away, I could have been blinded or deafened, or yeah, a safety moment there. Those old electrolyte caps can be hazardous, so be very, very careful. So those are my the ones that I can think of right now. The other ones I'm trying to bury and forget about. Anyhow, back to you, Eric.
All right, Al. Appreciate it. Great. That's good. Good stories. All right, Drew. Yeah, you are the penultimate contestant here. So,
well, I can't say that I have the scale of blowing up a tectonic scope, but when I build something, I never document what I'm doing because I'm going to get right back to it. And in this case, I was going to get right back to it. I put in a line. I built a regenerative receiver It's a little spy kit thing, little spy radio thing out of 4-state QRP. And it's always very hard to tell what the frequency is. So I had a digital frequency meter, and I thought, well, this is very useful. I'm going to actually see if this works. And I hooked it up once by tapping in right by the oscillator, and it worked. It was actually pretty good. And it was I just had a test clip in there, and I didn't actually, make note of what that was for. So fast forward, getting around to it about 6 months later, and I think they were having a night where they were having a slow speed CW net, and I was going to tune into this thing, and I thought, oh, this must be for a ground, and I grounded it, and that was the end of the radio. So took very little time. It was actually it didn't die immediately. I'll give it full credit. It tried hard to stay alive for a second, so now I get to rebuild it, and yeah, that's as glorious as I get. I mean, I have brushed against a spark transformer for a furnace, making a Jacob's ladder and foolishness like that when you're a kid, but those are just things you learn from.
All right. That's great. Okay. Thank you for sharing that, Drew. All right. Last but not least, Howard, got something to share with us.
Well, I'm kind of new. I'm kind of new at this, so everything I do is embarrassing. But I did do the same millihertz, megahertz thing on. I have a different rudimentary signal generator, and I did the same thing. And I wasted about a half an hour, or not a half an hour, an afternoon trying to figure out why I couldn't get that to work. So I did that, and then I guess the most recent was installing the wrong capacitor voltage-wise in the PA board that I'm working on, and it blew up. So that was the first thing I blew up. So that's pretty well it so far.
Was there a lot of smoke and explosion, though?
Yeah, there was a noise and smoke. So
Did you record it?
no, because I didn't. I was going to record once I started to try to put a signal into it, and this happened before while I was getting ready.
Well, I guess the saving grace from a personal protection point of view is that most of this crowd, I think, needs to wear glasses. So at least you got your eyes semi-protected from exploding caps and other things. But
yeah, I guess that's one advantage of age.
Yes, there you go. All right, very good. Okay, well, that pretty much does it for the assembled crew here. So appreciate that. That was kind of interesting and a little different from what we've talked about on the roundtables in the past. So yeah, just before we wrap things up, Peter, did you have a comment?
Yeah, just quickly, I found Dwayne's reference to the S9 signal source that actually was based on something that NorCal had done. So I put the link to Dwayne's article or his blog post into the chat. But basically, that diode that we were talking about is basically was just to drop the voltage down to get it down to a more down to a level that he wanted to get it to. That's all.
Ken, you have a comment?
Yeah. I have joined the group of Sigilant owners. I picked up myself the 1032, the SDG 1032 yesterday. So I have yet to unbox it. My plans were to retire this summer, sell the house, get out of Dodge, and then start building up my test equipment. Retirement's not going to happen now till next year now. And I said, screw it, I'm getting it. So yeah, I got I ordered it from RCC Electronics. I was in a email with Peter. I was asking him what he had, and he suggested this, and I took a look at it. It was new, but it was in an open box. So it arrived yesterday, and maybe this weekend I'll take a look at it and see how it works. 10 to 30 megahertz, 2 channels. Yeah, so we'll see how it goes.
Right, Cherry? Okay. Thanks, Peter. Hassan, sorry, Ken. Hassan, go ahead, please.
Yeah, I think Drew had a story about taking apart his oscilloscope. I did the same thing. I took apart my Tektronix scope because one of the voltage rails was busted, the analog ones, and then I put it on the shelf thinking I'll get back to it later on. And now I think I'm gonna have to retire before I actually get time to actually fix that thing. I think digging back into my memories, I found my ultimate embarrassing story. The first time I tried to build a circuit, my math teacher said, we're gonna make a club, and whoever wants to build an electronic circuit can come to my house and do it. So I go to his house. I'm sitting in his lawn. 10 minutes later, he comes out, hands me a piece of paper. I'm like, "What? This is the circuit. Go build it." I'm like, "Wait, you're not gonna help me?" No. Where do I get the parts? Well, we were living in an Exxon compound in the middle of nowhere. He's like, "Go to the nearest town and pick them up." So I do that. I go there. There's one electronics shop, and I start asking for him. Okay, do you have these resistors? Luckily, he had resistors. Do you have a diode? He hands me this big giant diode from a washing machine or something. I asked, "Do you have any transistors?" No, I don't have any transistors. A transformer? No. He gives me a line transformer. Was I needed an audio transformer and a speaker. I was supposed to build a musical horn. So I get this hodgepodge of parts, including something missing, and I took it home and I carried those parts around for the next 30 years. Never actually built the thing. I think I still have one of those parts now. But it's such a contrast to the way, like Frank has tested circuits and manuals, and everyone's got like the way you guys do this, do your build-a-thons, night and day difference. So I think about that every single time.
All right. Well, you're gonna have to scrounge up whatever components you still have in your inventory there and bring it to field day. Maybe we can assemble that musical horn. We'll finally toot. So.
I have the diagram. I'll bring that over.
All right. I'll sit on my lawn with a piece of paper. Get started. All right. Anyway, that is it. We've had 3 of us, I guess, have dropped off. So I think that's a sign. I did have a question for Charlie or a comment for him, but that's fine. I'll catch him afterwards. So thank you very much for your attendance and participation, everybody, tonight. The next meeting is the 3rd Wednesday of this month. That'll be our regular meeting, April 16th. The topic is actually Charlie is presenting there, which is VNA basics and intro to the nano VNA project. So that should be interesting. So looking forward to seeing you all there. And unless anyone else has comments, speak now or forever hold your peace for at least 2 weeks, or on groups.io. All right. Thank you very much, everybody. Have a good night. 7-3 to all, or 7-2, depending on your level.
All right. Have a
Take
good night.
care, guys.
Yeah,